Okay, so we're back with the third example of USubstitution. And one of the things that you're going to notice, this kind of is a division. It's a division problem, so it seems a little bit complicated. But when you notice I have a function of x cubed, I have this negative 2x to the fourth plus 5, and it's being raised to the fifth power. So I'm kind of leaning towards letting this negative 2x to the fourth plus 5 be the u. If you notice, you're going to take the derivative of this expression, you're going to get negative 8x cubed. The negative 8 I'm not worried about. What I'm interested in is the fact that you have an x cubed up here, and that's good news. So I'm going to go ahead and let u equal that negative 2x to the fourth plus 5. And I'm going to take the derivative of the differential, excuse me, of du. And so that's going to give me negative 8 as I anticipated, x cubed. The 5 goes to 0 times dx. And I want to go back and rewrite this so you can see it a little more clearly. Sometimes when it's a division problem like this, it's better to just rewrite it and separate everything so you can see a little bit more clearly what's going on. So I'm going to separate this into negative 2x to the fourth plus 5 all raised to the fifth power times x cubed dx. And it's the same thing. If you were to multiply this out, you would get what we started with. So this is completely legal. I already know my u is up here, so I'm going to go ahead and replace this with that. So it's the integral of 1 over u. It's still to the fifth power, so I got to keep that. But I still have this x to the third dx that's kind of not good because I have u's and x's and they got to go away. Unfortunately, it's not a perfect match. You see this x cubed that I got to get rid of? This doesn't say x cubed dx. It says negative 8x cubed dx. So that means I got to do a little more work. But since it's really just that negative 8 that's an issue, we can go ahead and divide by it on both sides. It's the same thing as multiplying by negative 1/8. And what I'll notice here is that I get negative 1/8 du, but I have exactly the match I need on the right hand side. I have an x cubed dx. And that is good news because now we can simply replace x cubed dx with what it is equal to in terms of u or du, negative 1/8 du. Okay? So see, you kind of have to think a few steps ahead on this, but once you do a few of them, it sort of becomes natural that the steps. So this guy gets replaced by negative 1/8 du. And as I said in video number 1, if you're multiplying by a constant, in this case the negative 1/8, it is perfectly okay, and in fact recommended to pull it out of the integral so that things are a little bit easier to work with, less stuff. So negative 1/8 integral of, and instead of 1 over u to the fifth, I'm going to go ahead and write that as u to the negative 5. Again, kind of thinking ahead that I'm going to do the antiderivative, and that'll help me a little bit. Just kind of go up here where I have a little more room. But taking the antiderivative, I'll go ahead and do the little trick, add 1, which will give me a negative 4. Multiply this u by the reciprocal of that, which is negative 1/4. Keep the same sign, just do the reciprocal. So I still have this negative 1/8, and now I have this negative 1/4. So that's going to become a positive 1 over 32. But it's going to be u to the negative 4 plus c. So I've now taken the antiderivative. And I want to mention in this video, and the others I did not, a lot of students ask, what happened to the du? It's the same thing that happens to the dx when you take the integral. It's part of the notation of integral. So once you do the antiderivative, it's gone. Don't worry about it. Bringing this u back down to the denominator, I get 1 over 32 u to the fourth power plus c. And the last step, please don't forget, is that you actually have to take the u and get rid of it. You have to replace the x stuff back into u. So this is going to be a little bit longer. 1 over 32 and times negative 2x to the fourth plus 5. That's all raised to the fourth power. Remember, that's still under 1 plus c. And that's it. That's the third example. Hopefully it's helping. in the next one, I'm gonna go over one with square root, and this last one is an actual AP problem. So I'll do those separately on videos. If you want to see those, go ahead and check them out.